Yellowstone Supervolcano. How USGS made an abnormal find after using NASA thermal satellite. Talon Horvitz Express UK reports USGS scientists and Yellowstone Volcano Observatory made a surprising discovery below the surface of Yellowstone. This was after using thermal mapping from NASA's telescopes, their satellite telescopes. And it was a surprise for them. The Yellowstone caldera, labeled a supervolcano because of its ability to inflict worldwide devastation. It's pinned between the states of Wyoming, Montana, and Idaho. The volcano is constantly monitored by the USGS for signs that a super eruption may be imminent. In 2012, USGS scientist Greg Vaughn, together with colleagues from the Yellowstone National Park, used satellite-based thermal infrared (TIR) remote sensing data from two NASA satellites, the MODIS and the ASTER. They used the probes to measure surface heat below Yellowstone National Park to monitor changes and identify any abnormal anomalies. This research, which was published on USGS website, revealed that Vaughn used nighttime MODIS data and established background thermal patterns to quantify how much temperatures would have changed to be detectable with modern space boom techniques. He said most natural thermal changes at Yellowstone within the past decade are around the detection limits of the technique, providing hope for future monitoring during more active periods. The ASTER data covered smaller areas with greater spatial detail, about 90 meters per pixel. Vaughn was able to use ASTER to create maps showing regions where abnormal amounts of heat were released, calling thermal anomalies, and also to estimate surface temperatures and other aspects of heat flow at Yellowstone. The study went on to reveal the areas with the highest abnormalities in the park, and it continued. Within the time frame of the study, the thermal areas with the highest temperatures and the highest heat flow were the Sulphur Hills near Yellowstone Lake and the Grand Prismatic Spring in Midway Geyser Basin. The ASTER-based estimate for how much geothermal heat was radiating away from all of the Yellowstone's thermal areas was 1,970 megawatts, which is comparable to measurements made with land-based techniques that take much more time to acquire than satellite measurements. This work provides the basis for future use of satellites to measure and monitor targets changes in geothermal areas around the world that are well below magmatic temperatures and have proven difficult to study with satellite-based technology. Yesterday, a magnitude 3.1 earthquake hit Yellowstone. It was recorded just 100 miles from Yellowstone National Park in Montana. So in other words, it was northwest of Yellowstone caldera. Though the tremors were small, they will still be of interest to scientists because of the high possibility of an earthquake swarm. And they have had earthquake swarms the past few days in Yellowstone as well as Long Valley Caldera, which is another supervolcano southwest of Yellowstone, and it sits in California. So Yellowstone has been having earthquake swarms, and the geologists are anxious, they're stressed, because they see hundreds of small earthquakes in a short period of time. USGS website explains since 1973 there have been over 48,000 earthquakes located in the Yellowstone region. Earthquake swarms, or earthquakes that cluster in time and space, account for about 50% of the total seismicity in Yellowstone and can occur anywhere in the Yellowstone area, but they're most common in the east-west band of seismicity between Hebgen Lake and the Norris Geyser Basin. Most swarms are small, the geologists say, and they contain 10 to 20 earthquakes and short, lasting for 1 or 2 days. But, however, large swarms that can contain thousands of earthquakes and last for months do occur on occasion. Earthquake swarms pose a threat and they can trigger a volcanic eruption, though scientists are unsure exactly how. Well, one thing that happens in Yellowstone, for example, is perhaps because of the fact that we have Yellowstone Lake sitting on top of the roof of the magma chamber. The previous Caldera Chronicles explained how even the wave motion can trigger an earthquake, especially the wave of Yellowstone Lake, because these waves are on top of the roof of the magma chamber. So earthquake swarms pose threat that they can trigger a volcanic eruption, though scientists are exactly unsure how. They believe the volcanic activity possibly occurs in response to the change in the local pressure surrounding the magma reservoir system as a consequence of severe ground shaking caused by the earthquake. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.